In this video, we're going to go over the example of finding the max and minimum when we're given an equation. We're going to go over 3 example problems. Here we have our 3 example problems. I'll walk through them in a very standardized approach and then have you pause the video and work through the third one on your own. Okay, so in general, when we're trying to solve for the maximum or the minimum of any parabolic shape, we have to think about what we know about the maximum and minimum. One important factor is the slope. So remember, slope is defined as rise over run. And when we were looking at linear equation, we defined this as a delta y over a delta x, or a y2 minus y1 over x2 minus x1. Now, that was fine when it was just a linear equation, y equals mx plus b, because it was just a constant value throughout. When we have a parabolic curve like this, we don't have a constant value. It's changing over time. And an easy way to represent that is if you look at this pen represents the slope. So on this side of this parabolic, the slope looks like that. It's a relatively large negative slope. As you move in the x direction, right, as I move tangential to this parabolic curve, the slope gets closer and closer to 0, right? The negative value gets smaller and smaller until when we reach the minimum, it's perfectly horizontal, which represents a 0 slope, right? 0 rise. So we know that when we have a max or minimum, our slope is equal to 0. So if we were able to describe the slope of any of our parabolic or quadratic equations and define it as 0, equal to 0, we can solve for it. Well, if you've ever taken a derivative or calculus class, you know that you can find the slope through the derivative. And if you have not, just memorize the quadratic form, the derivative form of the quadratic. So dy dx is how we define the derivative or the slope. So we break it up into each individual term. A, b, and c are constants, so it's just the derivative of x squared. The derivative of x squared is 2x. So this term is 2ax plus the derivative of bx. B is a constant, so derivative of x is just 1. So derivative of bx is b. And the derivative of a constant, the slope of a constant, right, horizontal line, that slope is equal to 0. So this is equal to 0. So the derivative is 2ax plus b. And we said the slope is equal to 0, so I can solve for x. So step 1 of this process, use dy dx at x min or x max and set that equal to 0. Then you will be able to solve for either x minimum or x max. Okay? Once you're done with that step, then we can use the quadratic equation and plug in x min or x max into y min or max a x min or max squared plus b times x min or max plus c. Right? So relatively straightforward process. So we're going to go through these steps and we're going to solve these 3 equations. So follow along. And like I said, if you have never taken a calculus class, just memorize that this is your derivative and we're setting it equal to 0. I think that's more useful, right? There's always forms you might learn from your class of memorizing a formula for the x min or max or y min or max in terms of A, B, and C. But it's a lot easier if you just memorize this form and derive it each time. It might be slower, but if you don't have a pen and paper, or if you don't have the solution in front of you, this one, I believe, is an easier one to memorize. All right, so let's take a look at that first example problem. All right, so we have negative 2x squared minus 2x squared plus 4x minus 1. What we're going to do is solve for the derivative first. So we have dy dx, and we're going to say if this is set at the minimum or maximum, this is equal to 0, right? The slope is equal to 0 at min or max. Then we plug in 2ax plus b. So 2 times a in this case is negative 2. And we're solving for at the minimum or max location. Plus b. B is 4. So this is, we can also write this as 0 is equal to negative 4. I'll write x min or max plus 4. So what is our x min or max? Right? If I move this term to the left, it'll be 4x min or max is equal to 4. So x min or max is equal to 1. Okay, so that's step 1. It's pretty straightforward. Step 2 was we just plug this value into this equation. Wherever the x min or maximum is, you plug that into the quadratic equation. That will be where the y min or max is. So y min or max is equal to negative 2 x min or max squared, 1 squared, plus 4 times x min or max, which is just 1, minus 1. So what do we get? We got negative 2 plus 4 minus 1, and that is equal to 1. So y min or max is equal to 1. So x, y, the point 1, 1 is either a min or max. So can we tell if it is a min or max? Yes, we can. Without looking at the graph, we just look at that a value. If a is negative, what's the general shape of the curve? It's going to look something like this. And I know this because y equals negative x squared looks something like this. Y equals positive x squared looks like the flip version of this. So if that's negative, this is a max. Were you able to follow along with that concept? All right, let's take a look and see if we set it up correctly. All right, so here's our graph. 1, 1 is our maximum, and it's showing up there. Great. Let's take a look at our second example problem. Here's our second example problem. Y equals negative 2x squared plus x minus 2.5. See if you can work this one out on your own. Press pause, and then we're going to walk through the exact same steps. All right, so if you had a chance to take a look at it on your own, we're going to walk through it together. We're going to say dy dx at x min or max is equal to 0. And this is equal to 2ax. A is negative 2. X min or max that I'm looking for, plus b, which is just positive 1. All right, so what do we get? We get negative 4 x min or max plus 1 is equal to 0. So this means x min or max is equal to This goes over, so it's going to be a positive value. 1 over 4, or 0.25, a quarter. Okay. This is a negative a value, so this will be a max, just like the previous problem. So I can get rid of this min portion. Okay, now we plug in this value into our quadratic equation. X, I know this is going to be a max, equals negative 2 x max squared, so I'll write it as a quarter, that'll be a little bit easier to work with, squared, plus x minus 2.5, I'll say 2.5. Okay, so let's write this out. Let's see, what do we got? We got negative 2. This will be over 16 plus 1/4. And let me just put this in fractional form. Let me do common denominators. This will be for 5, right? Yeah. This drops out. Okay, let's do common denominator of 8, just to keep it simple. Negative 1 for this term. This will be plus 2 minus 20. Okay, so minus 1 plus 2 is plus 1, so minus 19 over 8, or negative 2 and 3/8, or negative 2.375. So this is my y max. All right, and so my x y max is 0.25, negative 2.375. All right, let's see if this is what we have. All right, there's my graph. It's a maximum as expected because of this negative 2 value in the a term, 0.25 for x, and negative 2.375 for y. Excellent. All right, let's try one more problem. We have y equals 5x squared plus 2x minus 3. Press pause, give it a shot, and then come back and we'll see if we match what you get. So we worked out the derivative, solved out x min as negative 0.2, plug negative 0.2 into our quadratic equation, and we found y min was negative 3.2. And this is our graph that represents that. All right, so hopefully that made sense to you. So as a conclusion to all of this, the final solution for each of these three, we had a max at 1,1 for the first problem, max at 0.25, negative 2.375 for the second one, and a minimum of negative 0.2, negative 3.2 for the third one. If you have any questions, feel free to put it in the comments here, and we'll work through more example problems in the next video.